What's up? It's your old pal, Mr. Cook, and we are working on the Unit 6C group work. We got done with the solving individual parts with law of sines and law of cosines, solving the whole triangle with law of sines and law of cosines, and now we're moving on to the last page and the word problems. So with the word problems, it's mostly just, draw your triangle, because, they're all going to be triangles, and then solve for whatever sides or angles we're asking you to find. For number 13, it says Nicole is making a triangular frame. Of course, it's a triangle. All the diagrams are going to be triangles. Let's label it A, B, C. So the triangle for an art piece she purchased in New York City. How fancy. The frame needs a wood backing, so she needs to use a miter saw to make the cuts and would need the angles of the triangle to set the saw. If the sides of the frame are 18 inches, 19 inches, and 30 inches, then what are the angle settings that she needs for the saw? So we've labeled this accordingly. We actually won't need units for this other than degrees, but we can solve for these angle measurements in much the same way that we did for number 11, just using the law of cosines for each of them. Start with the biggest angle, so that'd be the angle B across from the largest side. So angle B is equal to the cosine inverse of, and then it's a fraction, so it's going to be these two sides squared and added together, so 18 squared plus 19 squared minus the side across squared over 2 times 18 times 19. And then, type it into your calculator. So have your calculator ready over there. Cosine inverse of parentheses 18 squared plus 19 squared minus 30 squared divided by parentheses 2 times 18 times 19. And then you get your angle measurement. So that's going to be about equal to 108.32 degrees. So there's one angle. Let's find the next angle. So that's going to be across from the next largest side. So that'd be angle A. And that's cosine inverse of, and then a fraction. So around A, we have 18 and 30. So that's going to be 18 squared plus 30 squared minus 19 squared over 2 times 18 times 30. And then we type it into our calculator. So cosine inverse of parentheses 18 squared plus 30 squared minus 19 squared divided by parentheses 2 times 18 times 30. And then you get your other angle measurement, 36.96 degrees. And then to find the last one, since all three of the angles have to add up to 180, just take 180, subtract away 108.32, and subtract away 36.96, and you get your last angle measurement. And it'll be approximate also because these values are approximate. So let's see what we get. 180 minus 108.32 minus 36.96, and we get 34.72. So 34.72 degrees for that last one. So pretty easy, right? Like as far as word problems go, you already know what the diagram is going to look like. It's a triangle. All you need to do is just kind of like solve for the missing stuff. Number 14, I really like this problem, but this is definitely a challenge problem for you. So it says in a robotics course, engineers are asked to make a robot and program it to walk in a triangular path and return back to its own starting point. If the robot starts at point A, so let's draw point A there, A, and it walks in a straight line for 50 feet, so it walks straight 50 feet to point B. And then instead of walking straight forward, what it does is that it turns 128 degrees clockwise. So 90 degrees would be here like that. So what it's going to do is turn more than 90 degrees, a little bit more, to 128 degrees. And then it's going to walk straight forward. All right, so let's see here, 128 degrees. There we go. And then it stops at point C. And then instead of moving forward, it turns 3 degrees clockwise. So 63 degrees would be, let's see, that's 90. So like somewhere like right over there. Oh, so I got to redraw where my point A goes to. So the robot actually started over here somewhere. Just to make my, drawing like somewhat accurate. There we go. Hey, there we go. And that's a 63 degree angle there. So it can walk back to point A. How far did the robot walk along its path? So in other words, we need to find the length BC and also the length AC. And then once we find all three of those, add them up, and that tells us how far the robot walked along the path. So we don't have any angles inside, and we only have one side length. So one thing that you can do is recognize that these are exterior angles, 128 and 63, and they're supplementary to the interior angles. So that means that this angle, angle B, is going to be supplementary to 128 degrees. So supplementary means they add up to 180 because they make that little straight line there. So if I take 180 and subtract away 128, that gives me 52 degrees. And then if that's a 63-degree angle, angle C is going to be supplementary to that. So if I take 180 and subtract away 63, that's 117 degrees. So now I have these angle measurements, and I can find this third angle over here. So the third angle is going to be, it's going to add up to 180 with these other ones. So 117 plus 52 is going to be 169, and 180 minus 169 gives us 11 degrees left over for that angle. Now it just becomes a law of sines problem to solve for the missing side lengths because I have an angle and the side across from it. So I do the sine of 117 over its opposite side, 50. That's going to be equal to the sine of 52 over its opposite side, y. And then also, a little bit later on when I solve for the other one, the sine of 117 over 50 is going to be equal to the sine of 11 degrees over its opposite side, x. So let's solve for y first. We cross multiply and solve. And what do we get for y? Let's use our calculators for that. That would be 50 times the sine of 52 divided by the sine of 117. And that gives us 44.22 feet. Now let's solve for x. So x, if we cross multiply and solve, we end up with 50 times the sine of 11. And then divide that by the sine of 117. And we end up with 10.71 about feet. All right, so now we just go ahead and add all this stuff together, and that gives us the total length of the path. So that's 50 plus 44.22 plus 10.71, and then type it up. So 50 plus 44.22 plus 10.71. That gives us 104.93 feet. And that's the answer for this one. That was a fun one. A little bit challenging to get the angle measurements, but once you got the angle measurements here, it was pretty easy to set up and solve. All right, and then the last one, this one's pretty easy. 2 searchlights position. Okay, so, it's already going to be a triangle, but 2 searchlights positioned 2 miles apart. There we go, 2 miles apart from each other. Let's call it searchlight A and searchlight B. 2 miles, there we go. Both spot an airplane in the sky between them. So the searchlight goes over here, the searchlight goes over here, and then we have like a little airplane. There we go. And the sky between them. One searchlight has an angle of elevation of 38 degrees. Let's give that to this one, 38 degrees. The other one has an angle of elevation of 51 degrees. Remember that angle of elevation is the angle that you make with the ground and going up, okay, elevating up. So we can solve for these side lengths if we need to. Which searchlight is closer to the airplane and by how much? Well, you could answer this question without knowing the side lengths. So from searchlight A to the plane is X, let's call it, and then from searchlight B to the plane is Y. As you know, I've been saying this a couple times already, the largest angle is across from the largest side, the smallest angle is across from the smallest side. So if 38 degrees is smaller than 51 degrees, that means that Y is shorter than X, and therefore searchlight B is closer to the airplane. So you could solve it without that, but then I added in this other part of it by how much. So you actually do need to find the lengths still, and that's actually going to be pretty easy because if we have 2 angles, we can find the third one by subtracting from 180. So 38 and 51, if I subtract those from 180, I get 91 degrees, so 91 degrees here. And from here, I can just use the law of sines. So the sine of 91 over 2 is equal to the sine of 38 over y. And then also I can use that same proportionality, sine of 91 over 2, and set it equal to the sine of 51 over x. And then I just solve for my y value and my x value by using the cross multiplication basically. So let's see here, it's 2 times the sine, oops, let me get that more in frame here. There we go. 2 times the sine of 38 divided by the sine of 91. That'll give us the length for y, which is 1.23 miles. And let's solve for x, again using cross multiplication, 2 times the sine of 51 divided by the sine of 91. And that gives us 1.55 miles. Okay, and then it wants to find how far, by how much, so we just find the difference. So 1.55 minus 1.23, and that just gives us, what would that be, 30.32, so 0.32 miles. And there's the difference. All right, so, oh yeah, and also which one is closer? So closer is going to be Searchlight B that we made. Okay, so that's it for this one. That concludes our group work as well. Expect about this much work on your test, maybe a little bit less. But yeah, the formulas will be given to you, so you don't have to memorize them, but you do need to know how to use them. And that's it for this video. Good luck on your test. If you guys need some help, don't be afraid to come and ask for your, ask for some help from your teacher. All right, good luck, guys.